Hello, and welcome to a new episode of our MBSE podcast. This time we talk about geometry modeling with SysML v2. And well, this time we don't have a guest. I had some technical questions for Christian about modeling geometries. And well, I must admit that I am not an expert in geometry modeling. And then we thought, well, let's make it a podcast and make our conversation public. So here we are. And the modeling geometry is part of MBSE, so we will discuss why and how in this podcast. Christian, why are you familiar with geometry modeling? Did you study it?
To be honest, no, I'm not a mechanical engineer, but while my studies at the university, I took a course on CAD modeling, and it was Unigraphics version 8.5. Nowadays, it's called Siemens NX. And this was my first touch point. Afterwards, I was at a institute which was handling much of PLM, and the core or the beginning of any PDM or PLM system is managing geometry. And so, you get in touch with it. You don't have a chance to run.
So, well, if you study mechanical engineering, you typically learn geometry modeling in more detail, right?
Yes. Regularly, yes. I still know universities in Germany who are, who are very in favor to do 2D drawings by hand, and if you want, you can make a CAD course, but most of the universities, especially if you look worldwide, then any mechanical engineer learns at least one CAD tool.
Okay. So, let's start with the basic. You already mentioned CAD, and 2D modeling, 3D modeling, maybe there's also 1D modeling, I don't know. What is it? What is CAD and so forth?
So CAD basically stands for computer-aided design. And it's the computer-supported drawing like people did, or mechanical engineers did in former times, on a big board in 2D with lines of different thickness and so on. You still might remember or have seen these old pictures where many hundreds of mechanical engineers are in one big hall and everybody has a big board in front of him. That's I don't know, 40 years ago, I would say, CAD came into the game. And
it's the MBSE for mechanical engineers, right? So they shift from boards to CAD, and we systems engineers shift from documents to models.
Absolutely, and it's absolutely the same discussion. I didn't have, because I'm too young for that, but my former boss, Martin Eigner, he told me he had, in the beginning of the 90s, the same discussion as we have now with MBSE. He had it with CAD, where people said, oh, we don't need that. We have our boards. It's everything fine. It worked the last 20, 40, 50, 100 years. We don't need CAD. And this is exactly the same discussion we have now with MBSE, by trying to convince people why it makes sense not to use documents, why it makes sense to use a system model, which is in the first step more effort. But later on, you have the big advantages.
Yeah, right, definitely. So, what are the basic facts in CAD modeling?
So if you never used a CAD model, you have to imagine that you're doing basic geometry in the beginning, and usually you are starting with a 2D sketch. That means you draw a circle or a square or a combination of lines and circles and so on, and you do a flat 2D sketch. And afterwards, you bring it into the third dimension.
Okay.
But
2D
before you
sketches,
can...
I can also draw 2D sketches with PowerPoint very well.
Correct. Yes, absolutely. That's called PowerPoint engineering. And no, but of course, it's not the same, but it's similar. What you can do in PowerPoint when you use different surfaces or different forms, and you have also these bool operations in PowerPoint where you can combine a square with a circle, for example, or something like this. But the really interesting thing in CAD is that you have very often constraints that you say, okay, this edge and the other edge, they have to be parallel, or a certain edge has to have tangentiality to a circle, or you have a different or a special angle between two things. So these are the constraints where you set up your 2D sketch at first. Yeah, and then we can go on.
Okay, and then, well, what I cannot do with PowerPoint is to extrude it into the third dimension.
Correct.
I think so. I have never seen that before. Would be great, but
yeah.
I don't think it's possible. But I can do this with CAD, and I assume in most cases CAD modeling is 3D modeling, right? It's not.
Yes and no. Yeah.
Oh.
So I would say the most common thing is to model in 3D, that engineers are modeling in 3D nowadays. But there is also a 2D export afterwards for manufacturing. So manufacturing is still very often dependent on 2D drawings, which are not the same as the 2D sketches, but it's similar. It's comparable. Yeah.
Okay. So it's like different views on a 3D model.
Correct. Yes, these are different views, sometimes isometric, sometimes from an X, Y, and Z plane on the different parts. Sometimes you have a cutting plane in between. I don't know if it's the correct word. Sometimes you have to look into a part to see how it's constructed or how it has to be manufactured. And this leads me to another thing in CAD, which you never have in something like PowerPoint. It's the CAD features, which are coming into the play, where you say, okay, I have an easy shape, a cone, or whatever I extruded from my 2D sketch. And now I need a drilling, or I have two surfaces which are in a 90-degree angle, and you need a fillet, so a rounded edge between those, or you need a pocket. A pocket is something which you can imagine like, it's the same also in working with wood. Yeah, so, there you have these. What's the English word for?
The outer part.
No, not the outer part.
Okay.
I'm looking for a word for a machine, but it's not a drill. It's rotating very, very fast. And
chainsaw.
No, not a chainsaw. But okay, maybe I will come to that later. These features are another thing that you definitely need. Another example, which is very common, is breaking an edge. So that you don't have sharp edges and you have this 45 degrees angle. Therefore, you don't need another shape or another geometry which you bring in as a negative geometry to cut this edge from a box or something. These are classic CAD features.
Okay. Can I also run simulations in the CAD tool, so that demonstrates or simulates how mechanical parts fit together and how they work together?
Yes, fitting and working together are two different things in CAD. So yes, there are tools like Siemens NX. They have an option to simulate kinematics. So this is possible. I also know it from, I think CATIA has it also. I can't imagine that they don't have this. Yeah, you can simulate this, but this is quite special. The other thing you mentioned is the fitting, and these are also constraints between different parts. So sometimes you want to achieve that the centers of the circles are the same and two surfaces are flat on each other or something and touch each other. These are also constraints, but in the third dimension. And I think we will talk about this later when we come to coordinate systems.
Yeah, so, well, now this is all about mechanical engineering. And why is it important for the systems engineer?
Yeah, that's a very good question. And yeah, I would say some of the geometry is already constrained by, let's say, requirements. So the big problem in the past was that, you had your requirements and you did your specification, and then the single engineering discipline started to model in their own tools and their own languages and whatnot. And why not taking this knowledge that you have a constraint, that something has a certain weight, a maximum weight, or a maximum diameter or length or anything which is already stated in a textual requirement, why not modeling it in a constraint and reusing this constraint in your CAD tool later on?
So, well, but when the systems engineer should know a bit about geometry modeling and CAD tools, should a systems engineer also know something about software engineering or electrical engineering or any other engineering discipline? Is it the same?
I would say it's helpful to be T-shaped, to have some knowledge in any major engineering discipline. I think that's very helpful for systems engineers in general. And I think that most systems engineers, especially those who are practicing systems engineering for decades, they have a certain profession. They have they're coming from one engineering discipline where they are specialists, and then they became generalists afterwards.
Yeah, right. Yeah, maybe a special thing about mechanical engineering is it's about the space, and we cannot ignore the space in systems engineering. Maybe we can ignore the electricity a bit in systems engineering, but not the space. It's space and time is important on the system level as well. So, well, in SysML v1, there was no option to model geometry. Well, of course, you could define properties and store length and width and all the stuff in the model if you like, but it was not explicitly supported. And now SysML v2 provides model elements for geometry modeling. Can I use now SysML v2 for CAD now and ignore NX and CATIA?
I don't think so. I wouldn't say that you can ignore it, but it might be very interesting in the future to see if the single CAD vendors are implementing SysML v2 integrations. So there was a very nice presentation from Hans-Peter de Koning in June of last year, where he showed with FreeCAD how to connect SysML a SysML v2 model with geometry, with the automatic generation of geometry in FreeCAD, which is a free CAD tool. And I did a similar thing with Marvin Manuri from Fraunhofer IPK in Berlin. And we wrote a paper for the next TDSE in Germany. And if our paper gets accepted, we can offer you another example and some sample code how to integrate a SysML v2 model into a CAD tool. And what we did, and I think also Hans-Peter did it like this, we also used the SysML v2 repository to make this happen.
How can I connect CAD tool with the SysML v2 tool? Is it a proprietary interface, so I have to create an adapter between SysML v2 and CAD, FreeCAD, for example?
If you want to have a direct integration, yes. If you want to make it indirectly via the API and services, you could do that on a standard way. And this is what we did. We wrote a little Python script for FreeCAD, which was calling the information from a repository. And of course, you can fill the repository by any SysML v2 modeling tool. In this case, it was the Jupyter Notebook implementation.
Cool. So, then I have a SysML v2 model with geometry information, and I have my CAD model, of course, with geometry information. And how do they play together? Or what is the typical use case?
The typical use.
Also, have the mechanical engineer and the systems engineer, no? They also must collaborate then.
Yeah. I think we have to distinguish two things here. So the one is the downstream engineering process where maybe a systems engineer defines a constraint which might be a parameter like a diameter or a length, a width. And the mechanical engineer later on directly reuses this value, like 9 centimeters of diameter or something. Another really interesting use case for the future, from my point of view, might be the way back to say, okay, we now have a highly sophisticated geometry, and the tool, translates it back into SysML. And then you can afterwards, let's say in a validation process or something like this, you can say, you can take this information and trace it back to the original requirement, or to a system block apart, or however you want to do that.
Trace back then also means that the mechanical engineer can see in the CAD tool the traceability to the system model. So I can click on an element and then it shows me the requirements behind it.
Yeah, absolutely. It's definitely possible. And that's my dream for a long time, that I have my little window on the right in my CAD tool, which shows me, let's take a simple RFLP approach, which shows me what function is my part I'm constructing right now. What is it for? And what are the original requirements? And to have a tick box like saying, okay, I fulfilled this requirement and this and this and this. And through this way, the mechanical engineer does systems engineering without knowing it. That would be great.
And without exporting and importing the data in the background, it's accessed through the API. So it's
absolutely
also a good thing. I was involved in a research project 10 years ago, long time ago, FAST4M, so functional architecture for systems for mechanical. And there we tried to push the physical system data to the CAD tool and the other direction. And theoretical, it was fine, but technically on the software level, it was too much for our research project. So we only had a very rough prototype for it, and there was no API, no SysML v2. Okay. Well, then let's have a more detailed look on SysML v2. So what are the geometry capabilities now of SysML v2? And well, our listeners from previous episodes probably know that SysML v2 is based on kernel, the kernel modeling language, which is, well, simply said, a modeling language for modeling languages. No? So you can create modeling languages with kernel.
It's a meta modeling language.
It's a foundation. And well, the capability of geometry modeling is already part of kernel. So it's not specific to SysML, it's part of kernel. So what can we find in kernel about geometry modeling? What's in there?
Yeah, basically it's the fact that geometry exists in time and space, and it occurs, it's an occurrence, and these are basic the foundations which are defined in kernel. And you can review this. We already linked below this episode the link to the SysML v2 pilot implementation, and there you can look up how it behaves and how things stick together. But it makes totally sense if you imagine that time and space also is important for not only systems engineering, for so many other potential modeling languages which could exist on the foundation of kernel. Maybe Tim, you are the FTF co-lead. Maybe you know even more about it.
Yeah, I know a bit more about it, but I'm not the FTF co-lead of kernel, but of SysML v2.
Oh, that's true.
Yeah, there are two FTFs. But yeah, of course, I also know kernel at least a bit. Yeah, there's this occurrence element in kernel, which is the most general classifier of things that have an identity and occurs in time and space, but must not. Of course, you can use occurrence also to model a software thing, data, which does not has space information. It's not a mandatory property of those things. And in kernel, but an action or a state is also an occurrence. It occurs in time, not in space, but in time. And kernel also defines objects. It's just named object. And an object is a structural occurrence. So anything that has a structure. And objects, in addition, also defines already some geometry information, but mainly they are defined there, not in the occurrence element. And basic things like points, surfaces, a body, and so forth. But that's kernel. And now let's switch to SysML v2. What's there?
Yeah, so SysML v2 goes more into in specific things. So so SysML v2 is then really knows about things like a shape, not just a surface and a body, which is very basic, but it even knows something like shape. It knows that a spatial item or a spatial object, I think it's called space object, structured space object. It might envelop things, envelop other things. This is more specific information, which is of course touching geometry.
So an enveloping shape is a shape that is around another shape.
Correct.
So
a
package if I order something in an online shop, the package is the enveloping shape and my product is in there.
Correct. And this was very hard to express in SysML v1, to be honest. It was possible, but it's crystal clear now if you describe it like that with a geometry library.
Yeah, and in SysML v1, it was not part of the language. No? Well, of course, I can define in SysML v1 a block named enveloping shape and add the properties, length, width, height, and something like that, but it's not part of the language. Yeah, and it's just data in the model. So, but that's the same in SysML v2. So what's if I model this in a typical SysML modeling tool, I enter the length width. So it's not a drawing tool, or do you expect that we can draw the geometry in SysML v2 modeling tools like we do this in CAD, or do we specify it by numbers?
Good question. I think time will tell us. I don't think that we really model everything in SysML. It would be like programming geometry in CAD, which is not really happening. Of course, you can have macros where you can use different CAD features to automate things. And with all the generative artificial intelligence things, this is even something else. But going back to classic CAD modeling, it doesn't really happen that a mechanical engineer writes code or uses a domain-specific language. Maybe this happens for special projects or special geometry. And if you have an example, leave us a comment. It would be very interesting to hear from that. What was our question? I don't think that we really model geometry via SysML v2. I can imagine, something like these enveloping shapes to define that there is an enveloping shape. The same is true for bounding shapes, to define something is solid or a void. Something has to touch another, one body has to touch another body or must not touch each other. There we are at electrical engineering, where sometimes you don't want that something touches. I think time will tell how much people will use it. So in the example from Hans-Peter and also what I did with Marvin is, we did this for basic shapes, and Hans-Peter did even model a basic model for a car and a drone, so a quadrocopter. And if you look into this presentation, which is I don't know if it's publicly available, but for OMG members it's available, definitely. You see it's a lot of code in because he did it in the textual notation. And it's even basic geometry. That's nothing which is really used in that way. So geometries are much higher sophisticated. And if you would like to model this, no matter if textually or in a graphical way, it takes too much time, I guess. But this is the interesting thing, the way back, so to say. You have a finished geometry, and you translate it back automatically in the model. That could be interesting for
and then you access the properties in a constraint or so, no? That the length of this one must not exceed that one, and things like that. Yeah, cool. That was Another interesting thing is what you mentioned, the touches, that a thing touches another thing. And in SysML v2, well, we have space and we have time. So the touches also consider the time, so that there is a snapshot in time where this thing touches the other one. Is this also the case in CAD modeling, that it considers the time aspect?
Yes and no. It uses the time aspect if you are bringing the geometry into simulation. Then you very often have the time constraints or the kinematic tryouts I mentioned before. There you have a kind of time, and then you can see something touches something and something has certain material, and this is why something moves or doesn't move. And it definitely is in these ways. Touching is a much bigger effort not an effort, a bigger story in CAD. So you have own tools, DMU tools, digital mockup tools, where you can test if something touches, if something collides, or how much it touches. So if you imagine a piston in a motor, and it shall move, but it does not have to have too much room to lose all the pressure and the oil and whatever. Yeah, it's a whole class of tools, these DMU things.
Okay, well, interesting. Well, in SysML v2, we have the model element item, and we have parts, which is based on item, but the geometry stuff is at the item element. So an item has a shape and have these enveloping shape that you already mentioned, has some functions. I can ask if it's solid or not, things like that. And then we have the library. It's a domain library in SysML v2. It's part of the standard, so it's normative. There's a geometry library. There are two sub-libraries, spatial items and shape items. So what's in there?
That's a very good question. I looked it up right some hours ago, and the one thing was definitely, I think it was the shapes, where you have typical basic shapes as let's say some kind of as an example, or not an example, but
there's a
rectangle, cylinder, rectangle, basic geometry, which is reused very, very often, and you don't have to construct your cylinder on your own, that you say, oh, it's a circle as a base, and it has a diameter, and it has a height, and so on. They are already there. You can use them.
I think the library also shows that it's really sophisticated to define geometry elements with the textual notation. So I hope that the future SysML v2 modeling tools will provide a basic capability to do this, not only with the textual notation, but also graphically. And SysML v2 provides a geometric view. So it's will be interesting how they implement that.
Absolutely. Maybe we get some CAD light even in SysML tools. Who knows?
So another thing is the other library, the name is spatial items.
Right.
And I think there we have also coordinate frames. So
correct.
Why is that important?
Yeah, the importance comes from, let's say in the end, from the bill of materials. So you have different parts. You don't have, so a car is not one geometry. It's a combination of many, many parts. And they have to touch each other at a certain edge or surface, and the problem is that you never know, or it's reality that these single parts, they have their own coordinate system. And if you're combining parts, you take two coordinate systems and you somehow have to rearrange them to give the correct end shape. And therefore, you often need to transform coordinate systems from one to the other, or you have to describe how these coordinate systems stand to each other. So these are mainly the information which comes in the spatial items library.
Okay. Yeah. So, and if I now would like to test it or play around with it, well, I can use the pilot implementation, Jupyter Lab, and well, I can then specialize a rectangle from the library and so forth, and play and define a car, but I cannot show it, right? So I can just do the text annotation thing, but I have no view on the geometry or verification that it's correct, that one thing touches another, or is it already possible to demonstrate it?
I would say it's not publicly available. So you have to do things on your own. So to my knowledge, there is no public free CAD integration, and I never heard that the other major CAD systems offered something like this. But maybe you have more information.
No, unfortunately not. So, and maybe that's because the geometry modeling was more the background, because it was not possible to use it or to use it. It was hard to do an example with it. And then when you created a SysML v2 model for this, then you could not show it. So it was,
Yeah, so it was very abstract, and you had to achieve what Hans-Peter did and what Marvin did, that you write your own FreeCAD integration, which is a desktop tool, so you can't show it like Jupyter Labs, which runs in the cloud. Maybe a cloud-based CAD system would be interesting, something like Onshape, if somebody is able to host this, and or PTC hosts it. PTC has bought Onshape a while ago. I
found there's a FreeCAD plugin for Jupyter Lab.
Really?
Yeah. But,
cool.
So maybe it's possible to combine it with the SysML thing, and you can use it as the CAD plugin for SysML v2.
Okay.
But
yeah, never heard from that. Really nice. We should try that.
Yep. But we need a programmer for that.
Yeah, maybe we look for somebody on the systems engineering Discord server.
Yeah.
In this community.
Yeah, maybe it's not so difficult to bring these things together. But
if there's an existing plugin, yeah, it could be absolutely feasible.
Okay, so well, I think we covered everything, or the on a high level, about this geometry modeling in SysML v2. We cannot demonstrate it, so we cannot show something. Maybe in the future, in a few months, maybe there's something available after your TDSE talk at the conference. Maybe. So anything else what we forgot? Or
I don't think so.
Then
I think we covered basic information for CAD related SysML stuff.
And we already talked 40 minutes. So.
Oh, yes. Wow.
So let's close the session. It's summertime, so enjoy your vacation, or maybe you're just before your vacation or so. And our next topic is about the NCOSY Symposium 2023, which was 1, 2, 3 weeks ago. And we will also talk about the NCOSY EMEA sector, because the EMEA director, Sven-Olaf Schulze, will be our guest. He was also at the NCOSY Symposium, of course. So he will report a bit what happens there, the highlights, and we will talk about the EMEA sector of NCOSY. And this is scheduled for August 21st. So in around 3 weeks, or exactly 3 weeks.
Exactly 3 weeks.
Exactly 3 weeks. So yeah, so I hope we see you there. And finally, do not forget,
trust us, we are systems engineers.
Bye-bye.
Goodbye.